Yeah. Okay, so hello everyone. In today's video, I'll be attempting the bi-weekly contest 178. Yeah, that seems good. Hmm. Okay. Hmm. Yeah, hopefully it goes well. Yeah. But a fan is running. Hmm. Okay. Okay. Three. So first one. First unique even element. Okay. Um, Sum of GCD of formed pairs, minimum cost to equalize. Okay, that seems like binary search on fancy numbers. Just equalize arrays using swaps. What are equal arrays? Okay, first unique even element. Nice. So given an integer in a norm, return an integer not in the first even integer earliest by index, it appears exactly once in norms. No such. Okay, so fine. So first we need chunk f is equal counter of norms. So for n and norms, um, if n mod 2 is equal to 1 is equal to 0 and n is equal to 1, return n 2 and minus 1, 2 minus 1, hopefully no incorrect. It's fine. So GCD of formed pairs. So you are given an integer array norms of length n. Construct a prefix GPD which okay. Construct a prefix GCD where each index I maximum of nums. Okay. Prefix GCD of I is the nums of I. Maximum of okay, fine. This is short prefix GCD in non-decreasing order. On the fine, let us do the GCD part first. So the max is equal to non star n. Okay, and then n is equal to length of norms. Okay, so for mx is equal to mx if I is equal to mxx. Okay, so prefix gcd is equal to non n n prefix gcd of I is equal to gcd of nums of I, comma mx of I. Fine. So prefix non-decreasing. So that's increasing order. So prefix gcd dot sort. And after that, form pairs by taking the smallest unpaired element and the largest unpaired element. 262 is the prefix gcd. 226 pair the smallest and the largest elements. 26. The remaining middle element 2 is ignored, thus the sum is 2. Okay, so 2, 3, 6, 8. 2 and 8 you pair, 3 and 6 you pair. Okay, so you ignore, thus the sum is 2. So the GCD of that is 2. Okay, fine. L comma R is equal to 0 comma x1 while L is lesser than R. That is plus equal to GCD of what is it? Prefix GCD of L x GCD of R. Fine, that should be good. L plus plus equal to 1 or minus equal to 1. I forgot to do that. Fine. Let's look at the third problem. That is 2 and 5. Seems good. Okay. So minimum cost to equalize arrays using swaps. You're given two integer arrays, nonce one and nonce two. Okay. I'm sure nonce two sign you can perform the following operations any number of times on the two arrays. Swap within the same array, choose two indices I and j, then choose either to swap nums of I and nums of j or nums2 I and nums2 j. Okay. This operation is free of charge. You can swap between two arrays. This incurs a cost of 1. Okay, return an integer denoting the minimum cost to make that is not possible, return -1. Okay, fine. So first of all, let us sort both the arrays. So nums1 dot sort, nums2 dot sort. Okay. And the first thing we need to do is look at the I think it's 10 power 5, right? So yeah, let's assume it's 10 power 5. So now so f is equal to contour of nums1, f2 is equal to contour of nums2. If f1 not equal to f2, return false. Nice one. So if it is equal, cost is equal to 0. Um um is equal to 0 comma n. Okay, so let us check if it's possible to do it in that much cost. So check of nums1 comma nums2 to A, B. Okay. Okay. Swap within the same array. Following operations any number of times. Swap within the same array. Choose either swap. Okay, this is the operation free of charge. Okay, swap within the same array. So this is just a hash map problem, right? So basically, uh, all num okay, set nums is equal to so num num n is equal to 1. Okay, so we basically need the difference. We need to, let us say, nums1 has 2 4s, nums2 has 4 4s. We need to swap the elements. Fine, so the differences should add up to 0. Then that would be okay. Then nums1 has 2 4s and let's say 4 5s and 2 5s. So for n and Sn, delta is initially 0. Delta plus equal to f of f1 of n minus f2 of n. If delta is equal to 0 is not equal to 0, expected invention law defined that is attribute horizontal lit. Okay. How many these things will I need? Okay. And what is the expected output? Okay, 0. If delta is even, let's print out delta here. Why is it 0 0 0? Delta plus equal to f1 of n minus f2 of n. is ended at, so fine. These two are fine. 10, 10, and 20, 20. Um, that is also fine. 10, 20, 30, 40. The answer should be -1. 10, 20, 30, 40. Okay, let's say minus delta 0 for the third one. Test Q minus delta. Of m of m. Um, and third one we need right here. First of all, delta current is equal to that. Delta plus equal to current. If current is mod to 1, then -1, fine. And then count is equal to absolute count plus equal to diff divided by 2. Zero, is it 2 again? Answer should be 1. Okay, wait. Number of swaps we require. Is it count by 2? Let's take another example. 10, 10, state 10, about 1, 1, 1, 2, 2, 1, 1, 2, 2, 1, 2, 2, 2, 2, 3, 3. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5. Fine, you can make this identical. Now, what's the answer? Answer is 2. Fine, 1, 2. Fine. 2's are done. One, two. 1, 1, 2, 2, 2, 2. 1, 1, 2, 2, 3. Yeah, I think this seems fine. Let's give it a quick submit. Okay, that was good. I mean, I wasted a little time thinking about whether it's right or wrong, but that was fine though. Fine. Okay. You are given two integers L and R. An integer is called good if the digits form strictly monotone sequence, meaning the digits are strictly increasing or strictly decreasing. All single digit integers are considered good. An integer is called fancy if it is good or the sum of its digits is good. Return an integer representing the fans integers in the range inclusive. The sequence is set to be strictly okay, that is fine. Sequence is actually wait. If its digits form strictly monotone sequence. That single digit integers are good. Okay. So 8 to 10. 8, 9, strictly increasing or strictly decreasing, right? Okay, 8, 9, 10. All three are. So 8 and 9 is good. 1 and 0, 1 strictly fine. 1, 0, what is the value? 10 power 15. Some sort of digit DP problem. Have a look at the rank. 1500. Not that great, honestly. Well, mm, yeah, the problem is can't iterate through all the numbers. So 10 power 15, 15 digits. The sum of its digits is good. How do I even solve this? No. The thing is, I haven't done digit DP, so I'm not sure how to even proceed with this problem. Well, a blank right now. Digit DP. Or is this some sort of permutation problem? Will people solve this again? 165. Not a lot. So my rank will be somewhere around 3 to 4,000. If the sum of its digits is good, an integer is called fancy if it is good, or if the sum of its digits is good. See, that's the problem. The problem is with the sum part. Yeah, this is quite hard. I'm going to end the video. Probably upsolve this after seeing. I'll see the solution after the contest is over. Yeah, I'm going to call it a day. Thank you for watching. Have a wonderful day. Yeah, I'll see you guys tomorrow for the weekly contest as well. Peace.